if we have an instruction something like this, MVI A32H, MVI A32H, what does this mean? Please pay attention. We have an instruction like MVI, move immediate A32H. This instruction is of 2 bytes. The first byte carries the opcode for MVI A, okay, an immediate value, and the second byte carries 32H, which is the embedded value. So this 32H is an immediate value which is residing in the memory. That means you are supposed to read this value 32H from the memory location 2001H, and that would be a memory read. Okay. Currently, this example is not so valid because why? Because this 32H is part of the instruction. So somebody could say that this is still opcode fetch. Okay, but we can use this example to illustrate memory read. Okay, let me say that if you are reading a value, move A bracket 1234H. Okay, this would be a very appropriate example. Okay, let me write that we have an instruction which is move A comma, okay, 1234H. Okay, then this would be an instruction which is reading a value from memory location 1234H and placing it in register A or the accumulator. So this is a move instruction. This is a move instruction from memory location to. So if you are supposed to read data from 1234H to memory location A, okay, to register A, then that would be a memory read event. Okay. So what happens in a memory read? How is it different from opcode fetch? There is no difference. Memory read and opcode fetch, actually both are memory read operations. So there is no difference between them. The only difference is that a memory read instruction is reading data, while an opcode fetch activity or operation is retrieving an instruction. That is the only difference. Both are accessing the memory, and both will take as much time, both will involve the same events. So we can easily copy paste our previous things over here, and everything will remain valid over. Will be applicable over here as well. So I will transfer this to our whiteboard. Okay, I will transfer this to our whiteboard like this. Okay, so let me try to do something. First of all, let me make things easy, okay? E. Everything is just the same. Number one event, address appears in the address bus. Okay, address appears in the address bus. Number two event, okay, I will modify this. Memory or data read start. Okay, so here we are starting our read. Okay, IO slash memory is 0 over there. Okay, the read operation has started at this point. I will change this read operation over here. I will drag this to our like this. So here memory data read start, and I will and here we have read complete. So everything is just the same. Everything is just the same. You can see read is complete. It takes three clock cycle. Okay, it takes 3 clock cycle and 3 T states. First of all, address appears. The address is 2001. Okay, and then in the second clock cycle, a read command is issued, and at that time, in data which is 32H appears in AD0 till AD7, and then in the third clock cycle, the read completes. Okay, that is all about our memory read timing diagram. Okay. Now we talk about memory write. What is the difference between read and write? Okay, there is nothing called opcode write. We never write our opcode into the memory. It is loaded by the operating system into the program, and that involves DMA, direct memory access. So we don't talk about opcode write. So we talk about only memory write. How does it do? Okay, let me, because I have to overwrite over here, so I will export it to our Microsoft whiteboard. Okay, now this is our memory write timing diagram, and I should explain. I do not need to explain the clocks. There are 3 clock cycles, T1, T2, T3. I do not need to explain over there because it is also accessing the memory once again. Once again, the memory is being accessed. So to make things faster, I will simply copy paste from there over here. Event number 1. Okay. Event number 1. So okay, so this is event number 1. Address appears in the address bus. यहाँ पर memory access गर्नु पर्ने छ है, memory access गर्नु पर्ने छ. So to access the memory, we need to provide the address first of all. So the address is provided in the first clock cycle. We are once again accessing the memory, hence IO/M is equal to 0. IO/M is equal to 0, ALE is equal to 1, and that's all. Okay. Now the only difference between a memory read and memory write is the command that is issued by the microprocessor, because it is supposed to write data, hence a write command will be provided. A write command will be provided, and that's over here. Okay. So this is the second event, event number 2. Event number 2. Write command write signal. Okay, the data that needs to be written to the memory also appears in the data bus, and this data is coming from the microprocessor to the address bus. Who is sending the data? The microprocessor is sending the data to the data bus. In our memory read and opcode fetch, the data was coming from the memory to the bus, memory to the data bus. Over here, the data to be written is coming from the microprocessor to the bus. Okay, the write signal is generated by the microprocessor. Okay, and you can see that the write signal is also an active low signal. You can see active low. See that it is low. Low. Okay, it is value of actively low signal is that which indicates something when it has a value 0. So it is indicate that the write operation is going on. Okay, when it is a value 0. Okay, and when it is 1, it means nothing else. So it is an active low signal, just like the read signal, the write signal is also active. Okay, and the write also takes time. In fact, write operation takes longer compared to read operation. Okay, and hence what will happen is that it will also finish itself in the third clock cycle. So it is taking 3 T states, and over here, okay, over here what you can see, this is write complete. This point is write complete. Okay. Write complete over here. So we have these 3 timing diagram, 3 events. Number 1, address appears in the first clock cycle. Number 2, write signal is issued in the second T2 state, and in T3 state, the write gets completed. Okay. Now we will talk about our I/O read timing diagram. Now, what is the difference between memory read and I/O read? Is that in case of memory read, the address provided is a memory address,